Welcome, everyone. Welcome to AI Integration Working Group weekly meeting. I am your host, Arda Güçlü. Today is September 24th. Before jumping to the agenda items, I see familiar faces, but is there anyone who would like to introduce themselves? Okay, I think we can move on to the agenda items. Daniela, would you want to take over?
Hey, I think Jakub could take the introduction for this topic, and then we will run a quick demo of the experimental implementation of the registry controller in Kubernetes. Jakub, do you want to go ahead?
Yes, let me figure out the sharing again on Zoom. Okay, looks like it's not allowed to share while someone else is sharing.
Actually, I checked all participants can share button. Oh, okay.
Right.
I think this one. Could you please try again?
Okay, I see replace current share, so I'm going to do
Yes.
that. And I think I can do just a second. Oh, I need to find the right tab. Sorry about that. All right. Okay. So the work we wanted to show is an MCP server registry. I'm presenting, but Daniela should get most of the credit because it was his idea. He drove the spec of this feature, the most of the implementation. So thanks you. Yeah, so what is it on a very high level what we did? We implemented a Kubernetes native implementation of the MCP upstream registry for use in your cluster. You can use it wherever you run your clusters, and you can host any registry you want, either the upstream one, your company is defined with whatever subset of servers in your cluster. So why did we do it? There was an in the MCP upstream, there was a registry project that had its first release. It's not GA, but the first, I think they call it still experimental released. And that MCP upstream project has two parts. One is a catalog, so it's pretty much a giant JSON with different MCP servers and their capabilities, how to run them, and so on. And also a hosted public good service. So there is like an API that you can query or list the servers, you can publish your own servers and so on. What is not in the MCP upstream is a way to run this server yourself with your own catalog. I think I might be wrong on this, but I think it was kind of their explicit goal. Anyway, at the moment, there is no way to run this registry implementation with the same API, so you could use the same client, but with just your catalog in your cluster. So we went ahead with Daniela and implemented that. Our goal from the start was to stay as close to the upstream specifications as possible. So the goal was that, okay, you will be running this registry in your cluster, you will populate it with your servers, but we wanted both the REST API of the service, the part that lets you query what servers are available, display information about them, and so on, but also the format the same. We were able to create the service that Daniela will be showing later on, and its REST API the same. We haven't been able to use the same catalog format. The reason is simply because the catalog format is not stable upstream, and we wanted to avoid kind of chasing our tail and keeping up with the changes. So because the implementation of the registry is kind of part of the toolhive project, which has its own kind of proprietary format that's older than the upstream, we did stick with that. But the plan is, as soon as the upstream catalog format is more stable and we can rely on it not changing so often, we want to switch to the upstream format. The purpose is not to be any kind of vendor specific. The purpose is to be the same as the MCP upstream. Raise the hand.
So maybe you'll get to it, but is this based on the upstream code, or this is entirely new code that you have written?
Both. So partially. One of the engineers who is working with me on toolhive is spending most of his time working in upstream. And one of his areas of focus, like the things that he developed in upstream, is a Go library that lets you query and inspect and I think even modify, but I'm not sure, the upstream packaging format. We want to use that, but as I said, the upstream format keeps changing, so we kind of said, okay, maybe in 2-3 weeks as they stabilize it. The REST API service, no, we wrote that ourselves. So the plan going forward is to keep maintaining our own the REST API wrapper. The REST service is quite simple. It's really, I don't want to say the numbers, but it's not that many lines of code. And there's nothing like maintenance heavy. As soon as the upstream format stabilizes, we'll be able to use the upstream code that lets you query the information. So at that point, the code that we maintain ourselves would be just like a REST wrapper around the upstream package library.
Okay, thanks.
Welcome. Yeah. So as I said, now for now we use the toolhive format. This is not the goal. We will try to converge on upstream. Note here is that the data in those two are pretty much the same, except formatted differently. Like the nesting of the keys and so on is different, but like the information you get is the same. Okay, and implementation details, because this is a Kubernetes meeting. We implemented a new CRD, custom resource definition called MCP registry. Daniela will show how it works. And then you define this MCP registry, and the actual catalog, the list of servers and its properties, can be read right now from a config map. Kind of the easiest way. We put everything into a config map or a Git repository. And Daniela has planned that we would soon be able to have cascade the registries or use OCR images. Because the catalogs might change, or new servers might be added, the image references might change, and so on. We want to sync the registries. This can either be done manually by adding annotations, or Daniela add this nice scheduled sync of the registries. And there is also the possibility to filter the contents of the catalog. So in the catalog format, there is something called text. So you might have like MCP servers that make up some example. You might only want to filter MCP servers that deal with Google services. So there might be tags like Google, and you filter only those. And then once the registry is synchronized from its source into internally used config map, it is exposed by the REST API that implements the upstream specification, and that's what clients can use. And now, like, hopefully this gave some idea so that Daniel, I can actually show what we implemented in action. Start the sharing.
Okay, let me start sharing on the screen. This one, okay. Once again. Okay, you should be able to see my desktop now.
Yes.
Yeah, I think you are. Okay, so this is the overall plan for the demo. Let me show here. So first of all, we will create some. Let's say that we are running the operator on a kind cluster, so it's local to my laptop. The controller is running with a local deployment, so it's not actually deployed on the cluster, but it's running the local Go code. And what we will do is to first deploy some servers using the existing MCP server CRDs. Then we will create some registries and see how to connect the servers to the registries, and also show how these registries can monitor the actual data sources. To do that, we will also use an experimental UI that we prepared for the demo. It's not public, it's not part of the ToolHive repository, but maybe it will be sooner or later. So let's do first let's follow the plan. So first of all, let me select one of the empty terminals. We're going to deploy two servers using the ToolHive definitions. These two servers, since they are not connected to any registry, they will be shown as unregistered servers. So if we look at the YAMLs, the servers do not contain the labels to connect to the registry. And after all, we don't even have any registry. So later we will see how to connect the servers to the registry properly. So this is the standard MCP server type. We specify what is the image, the permission profile, and other things that I think Chris has demonstrated in one of the previous sessions. And the next step for us, let's see this one. Okay, we can look at the status of the servers. It's running, of course. And we already saw it is they are displayed in the registry UI. Then next step is to create a registry. So we have other manifest to create the registries. Let's monitor with the Kube CLI. So we have two registry, AutoSync and ToolHive Daemon registry. We can go to the UI to show the status of the registry. Let's see this one. So the first one is connected to a data source of type config map. And if we look at the details, this config map, this one. So do we need to increase the zoom? Is it better? Probably. Okay. If we look at the manifest for the config map, the config map just contains one key called the registry.json with the content of the registry using the ToolHive format. So we have servers with all the different servers. In particular, we have 3 servers: Postgres, MySQL, and Redis. And yeah, if we go here, we see that there are 2 servers. These 2. No, not this one. Sorry, I need to refresh. Yeah, this one. And for each server, we can see the original definition from the registry in YAML or JSON format. And For each server, we can also offer the different properties. So whether it's an official or a community server, and we can filter. So there is one community server and the other are official. What is the transport protocol that are used? And still to remember again that when it is standard I/O, it will be anyway wrapped by proxied by a network protocol like standard I/O or HTTP streamable. Sorry, like SSE or standard streamable HTTP. The other registry instead comes from the official ToolHive registry data. So from GitHub, if you look at the link, and this is the link to the code base, which contains, I don't know how many servers that are curated by StackLock for being part of the ToolHive registry. But we filter this one. So if we look at the manifest for this registry, we also adopted we also specified some options to filter based on tags. So we only include the servers tagged by database, file system, or API. So that we exclude all the other servers. And then we can also filter by, if we look for database, we are finding all the servers that are matching, that are including this tag. So this one is tag database. And for each server, we show what are the available tools, what is the expected configuration in order to deploy a server, and soon we will also offer some instruction on how to manually install the server. And we will also have an option to deploy the server. The deployment basically requires to specify a name for the deployment. What is, in case of standard I/O, we have to specify whether it's proxied by SSE or streamable HTTP, that is the default. And then important, we have to specify the value for all the variables that are specified in the registry. We can set some default dummy values, and these will prepare the manifest to generate an MCP server that is deployed and then also connected to the registry. The connection with the registry happens using some labels. The labels specify what is the registry name, what is the namespace, and what is the server name from which we start this container. And then soon there will be also the option to deploy the server, which actually is under development. And that's it. So next thing we want to show, it's filtering a manifest. We covered this one. The fact that we are also exposing APIs, sorry, clear APIs to expose the upstream registry interfaces. So for each registry that we deploy, under the status API status field, we have the endpoint that exposes the API following the upstream schema. So let's do a port forwarding of this port to 8080, and then on another terminal, we run some of the APIs. First of all, we have standard APIs like the 0 servers. So this one, we run it. This one exposes 24 servers, but it's not using the upstream schema in the output, because as Jacobo has specified before, we gave up on this initiative because the schema is very unstable. Once it will be stable, we will also support the upstream schema. Using the same API, we can also expose a specific and individual server like Chroma MCP, and this will expose all the properties of the server, including the tags, the metadata, the permission profile, and so on, and the environment variables that we need to set up in order to deploy the server. And apart of that, we also have a proprietary API like the servers deployed that exposes the list of servers that are connected to the registry. At the moment, it's empty. We can run it later once we connect the unregistered server to the service. Okay, then what we want to show about the sync capability is to update the data source that is connected to one of the servers. This data source is now updated. It includes only 2 of the initial 3 servers. So if we go to the registries and see this one that is connected to the config map, it should include, after refresh, yeah, it should include only two of the, sorry, I have to force the sync. First of all, I forgot this one, because the sync is not automated. Once we, after we update the config map, the sync must be manually started. With the force sync operation, we basically apply an annotation, a trigger annotation to the MCP registry that automatically starts the synchronization on the controller. So if we refresh the page, I expect that soon it should come. No, it's not working. Yeah, expectation is, yeah, for sync should of server count is 2. Okay, this page is not updated, but I imagine that it should include only 2 of the 3 servers. Yeah, that's wrong. Okay. Anyway, that is the scope. The goal was to run the manual sync with this trigger. And if we'll go under the status field, there is one status field called sync status, this one, which should be executed, yeah. This time, but no sync required. Okay, probably it was not completed properly. We have to verify what happened. As we said, this is an experimental feature anyway. I hope you understood what is the goal of these functionalities. Yeah, I see. And next thing we want to show is how to connect one of the unregistered server to the to one of the registry. So we go back to the home page here and select one of the unregistered servers, and we connect this one to, let's say, the autosync registry, and we name it fetch again, like the original. Okay, this is the name of the server into the registry. It is exactly fetch. And so if we go under the registry, this one should include one deployed server, this one, that is the fetch. And if we look at the manifest now includes the missing labels to connect to the autosync registry. And this will work together with the enforcement feature that Jakub mentioned before, that is still under development. So we will see how the presence or absence of this feature will affect the deployment status of the servers. I think this is more or less everything that we planned to. Okay, what we can do is to run again the deploy feature, this one. Let's see if we run the deployment. Okay, because I exposed the wrong server. Let me port forward the other service. Sorry, the other service is called autosync something. Yeah, this one. So if I run the query to return the deployed server, that is a proprietary query, it returns the fetch server that is connected to the autosync registry. I think this is more or less everything that we have. Oh no, if you want, we can also try to connect one of the servers to Cursor. So this is something that probably Chris missed to show. So let's expose the proxy service of the fetch server to port 8080. Then I add this local 8080/MCP to the MCP servers of Cursor. So I go under the MCP section. I add a custom MCP. I call it fetch. Okay, exactly this one. If I go back here, one tool was enabled. So if I open the agent and I run a sample query like this one, use the fetch tool to load the file, and then I use the raw GitHub link for the license file. Let's check this one. I expect, yeah, it is asking me the permission to call the fetch tool, and then I give it permission, and it fetches the tool. So this is connected. So this is to prove that how we can use in an agent the links, the services exposed by the toLive operator. I think this is all that we had prepared. We are open to questions in case there are.
Thanks for the demo. So I think I have some questions. So I think the registration process basically is the source of that is maybe like something on some GitHub repository or some OCI registry, which then you are registering with this local registry / catalog. Did I get that flow right, or I missed something there?
Yeah, the source of the data is external, and we fetch it from different source types. For now, we implemented fetching from config map or Git repo, but as Jakub was saying before, we are planning to fetch from other registries, so from other registries compliant with the upstream API specification, or with OCI images or whatever. This is basically the flow that we have in mind so far.
So like, is that just like metadata registration? So do you actually where do you pull the content from? When you register, do you also pull the source for the server?
Yeah, when we start the registry, it connects to the data source and it fetches all the content into at the moment it's a config map that is connected to the MCP registry and owned by the controller. Later probably we can think of a different storage, but we are basically copying everything, you matching the filtering criteria so that we have a local copy of this data that was imported.
Okay, let me walk through a full example. Let's say I'm writing an MCP server in Rust. I push it to my GitHub, GitHub NoNLP Kubernetes Rust MCP server. Now I have a Docker file for it. I build that. I push it to say some like GitHub container registry .io/NoNLP Kubernetes Rust MCP server. So when you are registering, what exactly is happening? Is that image that I push to the GitHub registry getting pulled, or it's just the metadata that this thing exists on that OCI registry? So when you deploy it, it should be pulled from there. So what exactly the sync is doing?
No, basically we expect the data source to be in D2Live format, so to be a JSON file with the given we following the schema that we accept for the server registration. So we have the name of the server and everything already prepared. We are not at the moment managing the registration of servers starting from their container image or from their code base. This is something that I don't know we will ever do in the future. I don't know if Jakub or anyone else has a different opinion.
Okay, no, I get it. I'm just trying to understand the flow. So you have this file, it's pointing to a repository URL. So you have all this metadata about a server, which is stored in a config map or something. So the sync is just getting it into the config map or local database. Is that right?
Yeah, it is copying. It is copying the filter and content of the original data source into its config map.
Okay,
That's
and when you hit deploy, are you actually instantiating that thing? If so, how does the instantiation work? Like for example, in this case, it's just pointing to a GitHub repo, right? You don't necessarily have the runnable artifact. Is it the metadata?
Oh no. The server includes the specification of the container to run. This one.
Okay, right.
And also the specification of what are the environment variables that we need to set up in order to launch this container image. This is these are the fundamental information for us to trigger the server.
Oh, okay. Now it makes sense. Okay, so you also have a pointer to the container image. Is that like a required field, or there is also support for, oh, the GitHub repo has that metadata which includes the install, build, run instruction, so I can just use that, or
This is maybe more similar to the packages that are allowed to be used in the upstream repository, in the upstream registry, because they allow for specifying packages in different formats using npm or Python packages instead of Docker containers. At the moment, we only support Docker containers. If there are other packages, they need to be first built into the container images. That's the point.
okay, all right. I think thank you so much for walking me through the details here. So one more last question before I yield to Arda. So when you deploy it, where is it deployed? Can the target, and I'm like wondering, why should this thing even care about what is deployed, right? Because deployment is a separate thing from a registry. Like for example, if I have a container registry, say Quay or Docker distribution, it doesn't track what is running. It doesn't care. It just hosts all these things, and then some other entity is responsible for pulling from there and deploying it. So I'm a bit confused that what is the deployed thing doing, and why is it kind of merged with the registry/catalog view?
Yeah. The point is that we wanted to guarantee that the servers that are installed are comes from the registry that we also deployed, because the registry guarantees that these servers have been curated, and so they provide the secure functionalities.
Maybe it's easier to understand it through Kubernetes controllers. So there are two controllers. And by the way, right now it's what Daniela was showing what is part of a single operator, but that's just like for convenience and speed of development. The registry part could be, and we are thinking about it, be split into a completely separate project that, as you say, doesn't care about deployment. It just provides the
Exactly.
registry.
Right.
And then there is a separate controller. As I say, it's now, at the moment, it's part of the same operator binary and operator deployment, but there's nothing preventing the split. It's just really convenience for us. And this controller only cares about the MCP server CRD. And what you can say during reconciliation of the MCP server CRD is check if the MCP server CRD points to one registry that I have approved on this cluster or is running on this cluster. If not, if the image is not found in one of the existing registries, then we don't reconcile the server. But that's the reconciliation of the server deployment. It's not the reconciliation of the registry. If that makes sense.
Okay, I think maybe the question is, okay, like so what exactly are you looking at? Are you looking at that, okay, my server should only be coming from the GitHub using images hosted on GitHub container registries? So what is the granularity at which you are checking that, okay, this is valid or this is not valid?
So at the moment, and by the way, this is very fresh. This is something we merged about 2 hours ago. So when we are reconciling the MCP server instance, we also do a list of MCP registries in the same namespace. Look at all the servers that we iterate over the registries one by one, and for each registry we look at the servers that this registry provides and try to match the image of the server being reconciled with the servers it provides. And if we find the image in one of the registries, then okay, we go ahead and do the rest of the deployment and deploy. If not, then we say, I couldn't find a reference to this image in any of the registries, and we fail the deployment at that point.
Okay, awesome. Thank you so much. Sorry, Ada, go ahead.
Now, as far as I understand, there is a controller watches the MCP registry CRDs, And when clicking the deploy button from the UI, actually this controller converts this MCP registry to somehow MCP server. So ToolHive operator actually runs this MCP server. But my question is more about, for example, let's say I'm implementing an MCP server and host it in storing it in the GitHub. Do I have to build additionally image to run in an MCP registry resource? I'm looking at this, for example, this registry metadata, and I see that Alibaba Cloud ADB MySQL MCP server repository URL, and additionally there is an image URL. So I'm trying to understand the relation between them, basically.
So in order to be deployed, you need to have the registry. So to have the server image already built. So as I said before to Mrunali, the provider of the server must build the container image and then also generate the registry specification, the server specification to add to the registry. And at the moment we are not building the image automatically, and not in the Kubernetes environment. ToolHive can do that using the CLI, but this is not part of our goal at the moment.
Makes sense. Thank you.
Okay. Other questions? Okay, so I can stop sharing.
Thanks for the presentation. Is there any topics, comments today? If not, I think we can end up the meeting and I will give your 20 minutes back.
Yeah,
Thank
thanks,
you, and-
Jakub and Daniel. Yep.
Thank you.
Appreciate it.